Hi, and welcome to yet another interesting time in computer studies. My name is Blaise Ella, and in today's lesson, we're going to look at the part 2 of the topic Cables and Connectors under the theme Information and Communication Technology. In this lesson, we will find out the different cables and connectors that are used to establish a computer network. By the end of this lesson, you should be able to list network cables and also list network connectors. When computers are connected in such a way that they can communicate with one another and share resources, it is said that a computer network is formed. Well, not just computers, other network devices like hubs, routers, and our phones can be part of this network. Usually, a computer network can be established using different medium such as cabled medium or wireless medium. For this lesson, our emphasis is on the cabled medium, that is, network cables. A network cable is simply a hardware that is used to connect two or more computers as well as other networking devices such as hub, routers, switches. And network cables are used to send data between these different devices. There are basically three types of network cables, and they are the coaxial cable, the twisted pair cable, and the fiber optic cable. Now, let's take a closer look at each of these cables. We will begin with the first one, which is the coaxial cable. A coaxial cable is a type of network cable made up of the following components: an insulator, a braided shield, a conductor, and a sheath, also known as a jacket. Now let's look at these different components. The first component we have here is the conductor, which is usually made up of copper, and it carries electromagnetic signals. So from this image of a coaxial cable, this is the conductor, which is also known as the core. Now, based on the conductor, a coaxial cable could be a single core coaxial cable or a multi-core coaxial cable. Now, the difference lies in the number of metal wires that make up the conductor. For the single core coaxial cable, there is a single central metal, which is what we have here, a single central metal. Whereas for the multi-core coaxial cable, there are multiple threads of metal wires. The next component, which is the braided shield, protects signals from external interference and noise. It is important to note that the braided shield is built with the same material as the core. So from this description, where is the braided shield? Well, this is the braided shield. As you can see, it has same material as the core. The next component is the insulator. The insulator protects the core, and it also separates the core from the braided shield. Like I mentioned earlier, the braided shield and the core are made of the same material, and so the insulator separates them so that there will be no short circuits in the wire. So from this description, we can see that this white component here is the insulator. And finally, we have the sheath, which is also known as the jacket. It is the outer layer of the coaxial cable, and it protects the cable from physical damage. From this image, this is the jacket. Coaxial cables transmit data at the speed of 10 megabits per second. Now, let's look at the second type of network cables, and that is the twisted pair cable. The twisted pair cable is also known as the Ethernet cable or the RJ45 cable. Some categories of the twisted pair cable can transmit data at the speed of 1 gigabits per second at a distance of 100 meters. Now, the basic information about the twisted pair cable is in its name, the twist and the pair. Now, this cable has 8 wires, which comprises 4 solid colors and 4 striped colors. The 4 solid colors are brown, green, blue, and orange, while the striped colors are a combination of these solid colors and white. Now, to form a pair, the solid color and its equivalent stripe are twisted. So from the 8th set of wires, we have 4 pairs. 1, 2, 3, 4. There are 2 types of twisted pair cables, and this depends on how the pairs are stripped in the sheath. The first is the unshielded twisted pair cable, and the second is the shielded twisted pair cable. For the untwisted shielded pair cable, all the pairs are wrapped in a single plastic sheet, whereas for the shielded twisted pair cable, each pair is wrapped in a metal shield. So we have all 4 pairs wrapped in separate metal shields before all of them are wrapped in the plastic sheet. And the final type of network cable is the fiber optic cable. The fiber optic cable uses light signals to send data. These light signals are transmitted from one endpoint to another. The fiber optic cable is made up of the following components: a core, cladding, buffer, and jacket. This is a typical example of a fiber optic cable. So talking about the features, we have the core, which carries data signals in the form of light. And the core is made up of thin strands of glass or plastic, which carry data over long distances. From this picture, there are several fibers bundled in an external jacket. So let's pick out one of these fibers. This entire tube is made up of 2 plastic or glass. The inner plastic is the core, and the core is shielded in the cladding, which reflects light back to the core. The next component is the buffer, which protects the light from leaking, and the cladding is wrapped in the buffer. So this is the buffer. And then we have the jacket, which protects the cable from physical damage. Over here we have the external jacket. Of the 3 types of network cables I've described so far, the fiber optic cable covers the longest distance and has the highest speed. It can cover a distance of 40 kilometers at a speed of 100 gigabits per second. There are 2 types of fiber optic cables, and this depends on the number of beams of light that they transmit at a given time. The 2 types are the single mode fiber optic cable and the multi-mode fiber optic cable. Now let's compare them to see their differences. The single mode fiber optic cable carries only a single beam of light, whereas the multi-mode fiber optic cable carries multiple beams of light. The single mode fiber optic cable uses laser as its light source, whereas the multi-mode uses LED as its light source. Going on, the single mode fiber optic cable can transmit 1300 or 1550 nanometer wavelengths of light, whereas the multi-mode can transmit 850 or 1300 nanometer wavelengths of light. Finally, the single mode supports higher bandwidth and covers longer distances than the multi-mode, while the multi-mode supports lower bandwidth and covers shorter distances than the single mode. So far, these are the 3 types of network cables we've talked about: the coaxial cable, the twisted pair cable, and the fiber optic cable. I'm sure you will agree with me that you cannot directly plug these cables as they are into any network device or a computer. They first need to be attached to a piece of hardware known as a network connector. A connector is simply a hardware that terminates a segment of a cable or provides a point of entry for a device. Network connectors can be distinguished based on their physical appearance. So there are male connectors and female connectors. Male connectors, which are also referred to as inlet or plug, usually have a solid pin for a center conductor, whereas the female connectors, which are also known as outlets or jack have a hole that accepts the male pin. Now let's look at different network connectors for the three different types of network cables. So let's start with the coaxial cable. Network connectors for the coaxial cable include the F connector and the Bnc connector. This is a typical example of an F connector. So over here is the male F connector, which has a pin, and this is the female F connector, which has a hole that accepts the pin of the male connector. And over here is a typical example of a Bnc connector. This is the male Bnc connector. Here's the pin, and this is the female Bnc connector. Here's the hole that accepts the pin of the male. So this is what you usually get when the cable is attached to its connector. So next we have the connectors for the twisted pair cable. So connectors for twisted pair cable include RJ45 connector and the RJ11 connector. Here's a typical example of the RJ45 connector. It has 8 pins. And here is a typical example of the RJ11 connector. It has 4 pins. And this is what you get when you connect the cable to its connector. And finally, we have the fiber optic cable. And connectors for the fiber optic cable include the LC, SC, FC, ST, and DIN connectors. And so these are typical examples of each of these connectors for the fiber optic cable. And this is what you get when the cable is attached to its connector. And with this, we've come to the end of this lesson. But before we leave, let's have a quick summary. First, we learned that computers are able to connect with other computers and several other network devices through the process of networking. Next, we learned that networks can be established using network cables or wireless medium. We also learned that network cables are hardware used to connect 2 or more computers as well as other networking devices in a network. Going on, we learned that the 3 types of network cables are the coaxial cable, the twisted pair cable, and the fiber optic cable. In addition, we learned that a network cable is terminated using a network connector. We also learned that there are male and female connectors. And finally, we learned that some types of network connectors include the F connector, the Bnc connector, the RJ11 connector, the RJ45 connector, the LC connector, the SC connector, the FC connector, the ST connector, and the DIN connector. At this point, let's try out some exercises. Question 1. Which of the following is not a type of network cable? Here are the options. A. Fiber optic. B. RJ45. C. Coaxial. D. Twisted pair. And the correct answer is B. RJ45 is not a type of network cable. Let's try out one more. Which of the following is not a type of network cable connector? Here are the options. A. Bnc. B. RJ45. C. Coaxial. D. DIN. And the correct answer is C. Coaxial is not a type of network cable connector. With what you've learned so far, I believe you can now identify different types of network cables as well as their connectors. Till we meet in our next lesson. Bye-bye.